Hi class, today I'm going to go over how to use Excel to perform a hypothesis test when you are provided proportions instead of means. There are a few conditions that you should consider in order to perform the calculations. Those are the sampling must be random, the data should follow a normal distribution, the sample must be of sufficient size, and there should be two outcomes, success and failure. Success and failure are kind of defined differently than what you would traditionally think of. It's just more like it could be a yes or no that this outcome does occur, or it could be yes or no this observation was made. So now that we know what the conditions that need to be met, we can look at an example. An online retailer has developed a new process to ensure that orders are packaged correctly for shipment. The previous process filled orders correctly 85% of the time. Based on a sample of 100 orders using the new process, 94 were filled correctly. At the 0.01 level of significance, can you conclude that the new process has increased the proportion of orders filled correctly? Let me fix this typo that's bothering me. Okay, so now we know what our problem is, and we're given certain data in the problem itself. So what I like to do is to set things up so that everything kind of flows in a logical manner. Have a setup on the example tab. I'm also going to fix the typo here. So here we have our data. I'm going to merge and center this. This is just more for formatting for my purposes, and so everything can be clear. We have the null hypothesis, which is P is less than or equal to 0.85. That's due to the previous process filled orders correctly 85% of the time. The level of significance was given, that's 0.01. The number of successes was also given with the new, based on the sample size, and that was 94. The sample size is 100. And you can see that this is here, this information, highlighting it in red, because that's very important and is significant for your next steps. Then we go to the next steps after you have your data set up. We will have the intermediate calculations. For this problem, you need to know what your sample proportion is, and that's pretty much 94 over 100. The formula is over here to the right, number of successes divided by your sample size. And then we can do standard error calculations. And here you can see the formula where it feeds from, and it also pops up on the screen when I highlight, but it's also right here to your right. Then we do the z-test, the statistic calculation, and that's the sample proportion minus the null hypothesis proportion divided by your standard error, which you calculated here. This is why those intermediate calculations are necessary. Once you have this 2.52 z-test, the statistic calculated correctly, then you can use a z-test statistic calculator to look up with the p-value, or you can use the table that you can Google. But the answer is 0.00587, which using the p-value approach means that you must reject the null hypothesis because the p-value is less than 0.01. If you have any questions about this example, please feel free to reach out to any of us. We are here to assist, and if you need any more examples that are kind of similar to this, or if you run into a question that might be slightly different, please let us know. Hope this helps.